Awesome. Welcome back, everyone, to our final manufacturing month celebration. Today we have Justin Gradek from Oregon Manufacturing Extension Partnership, also known as OMEP. He's here with something a little bit different than what we've normally done. He's going to walk us through a presentation that features some videos from local manufacturers who are doing some pretty cool stuff. And then we also are joined by Justin Thibodeau from our team at Connected Lane County. Hi, Justin.
Hello.
Awesome. Alrighty, so I guess let's get it started, Justin, with your presentation.
Yeah. Okay.
Yes, sorry, OMEP, Justin. I'm going to have to be better about this.
Thanks a bunch. Thanks a bunch, Lizzie, and thank you very much for Justin Thibodeau, and it's a genuine pleasure to join you folks here. So I work for an organization called OMEP, the Oregon Manufacturing Extension Partnership. And what we do is we work with small and medium-sized manufacturers around the state. Basically, we get some federal grant funds and we do all kinds of things for manufacturers. And we love what we do. And I'm going to talk a little bit about some of the exciting advanced technology stuff that small manufacturers are starting to adopt these days. Quick question for you, Lizzie, is actually, never mind. We'll just roll with it.
Okay.
So a tiny bit about me, why I came back to manufacturing. I just want to hit on this for a second here. So I've had a whole bunch of different jobs. I've worked in a bunch of different industries. I started my career working as a wildland firefighter. Then I went into manufacturing and construction. And then I worked in restaurants and went back to school. And I ended up in government and worked in federal U.S. Treasury for a little while. And after that, I came back to manufacturing. And there are a couple of good reasons why I came back to manufacturing as an industry. And I wanted to share that with you all because it took me a while to figure all of this out. But there are a couple of things about manufacturing that I absolutely love. One is that we make a product, we make something. In other jobs that I've worked in the past, like working in the federal government, well, I got to do some really cool things and and be a part of a bigger system. I wasn't making things, and I'm a person that I found out that I like to make things. I like to make things with my hands. I like, I used to like going to maker spaces. I know Justin Thibodeau has some things to share with you all about the space there in Lane County. So making things, manufacturing. Also, these days, manufacturing provides some great wages. There's a lot of good money to be made in manufacturing. We also find that there are tons of opportunities to solve some super tough problems that companies are dealing with. So we get to use curiosity, critical thinking, run experiments, kind of run the scientific method. Another big topic here is opportunities to be a part of a growing business. So there are a lot of manufacturers out there that are growing rapidly. They're adding products, they're adding capacity, they're adding new customers, they're adding basically the need to be able to grow the business. And so whenever you grow a business, you've got to figure out how to scale it up and how to meet kind of tight labor force issues and basically do what you do, but do it better and do it faster and do it with the same number of resources. And so that takes a lot of interesting creativity, which has always been fascinating to me. Another great thing about manufacturing is you get to learn some pretty high demand skills. So I would liken it to working in the trades, and you get access to seeing how hydraulics works and pneumatic systems and fluid dynamic systems on the engineering side. There are entirely other parts of manufacturing that you get to learn the basic skills of running any type of business. So human resources, marketing, sales, financial management and doing the books process, supply chain stuff. Manufacturing basically has it all. And then my personal favorite, or the one that I really spend most of my time on these days, is access to advanced technology. So before I jump into that, a little bit about OMEP and what we do. As I mentioned, we work across the state. We work with small manufacturers from primary metal and wood processors to food manufacturers to people that make everything. We do it all. We do clothes, we do food, we do We do, primary wood processing and material processing. So starting from there, historically, when it came to advanced technology and manufacturing, the companies that had access to advanced technology were companies that were really large. So I think Fortune 500, Fortune 50 companies like Bosch and Lomb, 3M, Boeing, Lockheed Martin, big companies like that, Medtronic. They had the engineering resources to put towards figuring out what are the right new technologies that we should be adopting and where should we put them and how should we integrate them, and then what's the value that they're going to return to us. And so they were equipped, these large companies were equipped to answer those types of questions. Being that we live in the information age, we all have access to Wikipedia or whatever your favorite resource is, Reddit, however you get your information, there's a democratization of information that allows any of us to become expert in the finer and finer details of bringing advanced technology into a manufacturing environment. And so what that has done really for our industry is it's allowed small manufacturers to adopt some of these more advanced pieces of technology. So what we'll go through are some of those that end up being really, really good use cases and good fits for small manufacturing, and talk about what's exciting and fun about those things. So let's talk a little bit about the cloud. There's always a lot of hype around the cloud and web applications and mobile applications. And we believe as a society that if we can put the right technology in the right place in a manufacturer, it will invite and open the opportunity for efficiency gains. Remember, I talked about you've got expanding businesses that are growing, and you need to be able to really make the same amount or more with the same or less resources. So the same or less number of people, same or less number of various resources that you can call upon. The way that a lot of companies have become more efficient in the past 20 years has been harnessing web applications and software that help them organize their data. And the cloud is really how we do a lot of that. So there's a whole family of softwares called ERPs, Enterprise Resource Planning softwares, that help companies organize their financials and organize their production schedules and organize their supply chain. And bringing one of these software packages into a company has historically been pretty difficult and challenging. But what we've been working on as an industry is making it easier and easier and easier. So at OMEP, we've been putting together kind of a suite of cloud services that make this type of digital transformation a little bit easier. Lizzie, I'm going to stop here and see if you have any questions so far. Is this making sense so far?
Yep.
Okay, awesome. So the cloud. Once we start doing things in the cloud, we can capture all kinds of data. We can capture work instructions. We can capture basically, sort of job paths. So when somebody comes into a company, they know what they need to do and what they need to get trained on in order to move to the next level. We can keep track of maintenance schedules. We can do all kinds of great and wild things. These are some of the typical use cases that small manufacturers deal with. So document management, as easy as you would think that it is to keep track of information, document management is kind of a critical thing, because you have to know what the current right way is to make things. And so we need a good structured standard way of doing that. Standard work is all about writing good work instructions on the best way that we know how to do things. Training in LMS is all about using those standard work instructions to put together a structured training plan for people to know what they're doing. Quality management system, continuous improvement. Total preventative maintenance is about knowing how frequently you're maintaining your equipment so that it stays up and running and being productive for you. Industry 4.0, of course, is a topic that covers all kinds of other ancillary technologies. So if we were able to engage, I'd say, hey, who's really interested into augmented reality? And augmented reality is this concept that we can layer
inside the OMEP.
augmented reality is this idea that we can layer the digital world over the physical world when we're wearing some type of either head-mounted display or a mobile device. So this is the kind of stuff that you would have only seen in Iron Man, like maybe 5-10 years ago, but it's really starting to come down to the factory floor in small manufacturers. There are a ton of use cases. So delivering job work instructions is a really good use case of augmented reality. Imagine a world where you show up to a company on the first day, they put a headset on you, and they go, okay, here's the job that you're going to be doing. Here's the place that you're going to be working. They spin up the program, and you start to walk through step by step the various pieces of doing this job, and you begin to train yourself on how to do it just wearing the head-mounted display. It's a super engaging, fun, interesting way of learning how to do a job. It's totally doable right now. It's really affordable for small manufacturers, and there are use cases that we can do at the moment. There's also another use case that resonates with a lot of folks in the industry right now, which is all about capturing the work that they do. So it's common to go into a manufacturer where you've got 1 or 2 people that know how to do something that's super specific and fairly maybe arcane or not very well understood on how to be done by other folks. And what we can do is we can put a headset on them, and we can press play, and we can have them go and do their job and set up the machine or do whatever it is that they do. And they will, in turn, we'll be able to record what that job is and get a sense of here's how they actually do a job. And it becomes a more interactive experience for the next person that needs to learn to do it than if we were to just video how they do their work. So augmented reality, it's pretty exciting stuff for us.
Can I just jump in briefly, because this is very exciting? I look at this and I immediately think of how much better young people might be at this than older generations that are trying to learn it. So for example, things that students are doing in their everyday lives, like social media. Like there are jobs that you can get where you work in PR, you work in marketing, and you are on social media, and it's a total benefit that a young person's life is often kind of engulfed in social media. So this feels like a really cool example of how a student could kind of nerd out on this in their personal life and then bring it to work.
Absolutely.
Yeah. Anyway, yeah, it's exciting.
That's a great point, Lizzie. And you know what? The shall we say the more mature, the older generations, the people in my folks era or the generation beyond me, they don't find this stuff as interesting. But you know what? This is really the future of what manufacturing looks like. And so anybody who comes in who feels excited about it, they can kind of carve out some niche space and become a really valuable part of the organization. I'm going to move on to the next one here. So virtual reality. I would say by show of hands or thumbs up, who's interested in virtual reality? So this is a similar technology, of course. Think about an Oculus Rift or an Oculus Quest. And if anybody's into virtual reality games, imagine you show up to a job interview and the person interviewing says, hey, do you want to try the job? It's like, yeah, of course I want to try the job. And they put a virtual reality headset on you, and you get to play in the virtual world with the tools and get to know and understand the process and the product, and get a sense of really where this company is going with their technology integration strategy. So there are all kinds of jobs from the front to the back of bringing this technology in-house. So manufacturing needs people who can build virtual reality simulations. Manufacturing needs people who can explain the process of what the simulation needs to do, and then also people who can deploy those, basically get those simulations into the workforce. So this is a company that we work with. This is a company called Woodfold up in Forest Grove. They make accordion folding doors that you would find separating like community rooms or something. They kind of look like, maybe you even have some of them in your schools. And the idea is that they kind of give thermal and audio protection in between spaces. And it's not a super exciting product by what some people would describe, but we have figured out how to make it really engaging and interesting using this virtual reality training tool for anybody who's coming into the workforce. We use virtual reality in a couple of places. So we do a lot of facility layouts. So imagine you're working in one of these companies and you go, hey, we need to increase our capacity. The first thing that they usually think about doing is, how do I make more of the space that I currently have? And the way that we then make a facility layout is we will create a building in 3D space using Autodesk Revit and Inventor and put everything in there that currently exists. This company down here on the bottom, you see the person kind of walking around. This is Cobots Sawyer in Independence. Maybe some of you know of it. And then what we do is we start figuring out, okay, what does the new space need to look like to accommodate the increased capacity that the company needs to be able to produce at. So with Marquis Spa, what we did was we took everything off of carts and we put it on roller conveyor. And we had this great 3D model in the end. And so we took everybody who's going to be working in those cells and we put VR headsets on them and we had them go walk around and experience what it was going to be like to be in their new space, because we were moving them completely across the factory, giving them a different set of tools. They were going to be working in a different place relative to where they had been, with their friends and kind of what they've become used to. And so virtual reality facility layout simulations or product development is a pretty cool, powerful tool that manufacturing needs people on basically all sides of being able to do these projects. This top one up here is a company that I work with called Summit Body and Equipment up in Portland. They make truck bodies, and we're moving them into a new factory. And so myself and another colleague, we were having a heated debate, spirited argument, some people might say, about what the best way was to move the products along the line over the course of a line roll. I was saying it was the best to do it using these yellow bridge crane. He was saying it's best to use carts. And so we thought, you know what, let's just solve this by instead of trying to talk about what we thought was right, let's just show what's right. And so I simulated both options. He won the argument, and I was happy to concede that I was wrong, but we all learned a lot in the process. And any new employee who comes onto the production line now, we can explain to them why it's important for them, why their job is important, how it connects to the rest of the whole when we're trying to move the whole line together. So that's that story.
Well, how cool that you learned that your idea was not the best after they had done a multi-million-dollar renovation.
Yeah. Yeah. Well, fortunately, we learned it before we bought the bridge cranes. So yeah, so we saved them. I think we actually saved them about $250,000 by not doing it my way. I'm happy to concede, but it's just the power of simulation is incredible these days. In the past, all of these types of decisions used to be made by executives in the company, and now we can get somebody who does the work into the simulation, have them give their input on how these changes will affect their life and the movement of the products. And these are not huge companies that we're doing this for. These are everyday kind of average size companies. All right, next one. Okay, so here's a project that I'm super excited about. So if I were to tell you putting sensors into factories is potentially useful if we can find the right sensors and we can put them in the right place, you'd probably say, yeah, you're right. We just need to find the right sensors and find the right place to put them in. Now, the way we historically do projects like this is we'll go in and we'll start talking to the president or the CEO of the company and start talking about, hey, sensors are really great. They can be awesome for your factory. We just need to find a right place. And they'd say, okay, great, go talk to my operations manager. So we go and have the same conversation with them, and then he'd say, great, go talk to my production manager. And so we go have the conversation with him, and then he'd say, go talk to my foreman, on down the line until we finally find the right project and the right sensors in the right place. So if you have your cell phones, I don't know if it's okay to ask for this, pull them out, read the QR code, and what you'll find is, and what's going to open up is a dashboard with a bunch of data that's being read onto the dashboard. So if you go back to my original challenge, we've got to find the right sensors and we've got to find the right place. what we've come up with is a way to hopefully shorten that education curve. And I hope that we can share this here with you guys. If you were to scan that QR code, it would take you out to a website that
Telling this.
is it. You still seeing my screen here?
I don't see the website on your screen, but I did follow the QR code on my own phone.
Did it open up a thing for you?
Yeah, sure did.
Okay, great. So this device takes 24 sensors and it packages it into this thing that's about the size of a brick. And we can start talking about now with our clients the different ways that these sensors are useful. So the sensors that you are seeing are there's a geolocating one right now. Of course, this is how live demos go. I'm having a hard time pulling it up. And it's just because probably I have a bunch of things going on right now on my computer. But there are a couple dozen sensors on here. They do all kinds of stuff. They'll tell us a whole bunch of different potential things, and some of them are useful in different ways for different types of factories. So I'll kind of run through them really quickly here. And if you want to get any more deep into it, you can click on this little link over here that says click here, and they'll bring you over to another website that talks about all the use cases. So you've got a location sensor in here. So this is using a cell tower telemetry. Basically, it's bouncing off of a bunch of different cell towers, and it knows roughly where I am. So if you zoom all the way out, you're going to know where I am. It's only accurate to about 4,000 feet. So obviously I'm not sitting right in an orchard, but I'm not far from there either. I'm actually over here on the hill somewhere at the moment. Location data. So where would location data be useful for a small manufacturer? Well, let's just say you've got a bunch of pieces of equipment like trucks that are going out and then making deliveries every day. If we put GPS sensors or location, geolocation sensors that are using these cell phone towers to know where the truck is, we'd have a good general idea of where the fleet is running around. Ambient temperature. So most of the companies that we work with are doing some type of chemistry where they care about temperature. Either they're working with resins or they're working with food where you don't want it to get too hot, or there's thermal expansion and changes to the way that a product is made if it gets too hot or too cold. Keeping track of ambient temperature and relative humidity is a pretty common thing that most companies care about somewhere, some way. And in those conversations, as we kind of go from the president and CEO on down through the ranks, what we're looking for is who's the right person that knows something about where we could use one of these sensors and actually have it be useful for the company. Barometric pressure, that's all about pressure in the atmosphere. So you can use a combination of barometric pressure in order to know what your altitude is, which is pretty interesting. Turn on the green LED light. So this is all about bidirectional communication. There's a 9 degree of freedom sensor here. So as I kind of shake this thing around, you'll see that the accelerometer, magnetometer, and gyroscope start moving around. So an accelerometer is how you measure vibration. And as you kind of get into the weeds of these, if you had equipment that failed predictably every single time, we could start talking about putting a vibration sensor on that piece of equipment, knowing that a bearing is gonna break in a predictable way time over time. So these are just examples. We could go obviously a whole lot deeper here. Particulate matter, we've got a great little distance sensor here, which is kind of interesting and fun. So as I move closer and away from the box, you can see that jump around. But these are examples of what the future of manufacturing looks like, where we get a good understanding of what sensors can do for us, and then we start looking for places where they're useful. So for example, yesterday, I was over in a manufacturing plant in Portland where they make, let's see if I have the video up. I don't. Yeah, unfortunately I don't. So this company makes a fried confection snack, and they use infrared temperature heat guns to test the temperature of the oil before they drop the product in, and it cooks. And what happens is you have a temperature curve in this vat of oil where the curve drops and then it comes back up again. And once it comes back up, that's when you know when to pull it off. And so you end up with a product that's similar to like a batch fried kettle chip. So it's crispy on the outside, nice and kind of juicy and soft on the inside. But making sure you get that curve right is important. So if you're using a handheld temperature gun, you're always going to be temping in between temperatures. And so we've added our wall-mounted infrared temperature sensors that look down in these vats of oil and we keep track of the temperature all the time so that we can drop and pull right at the right temperatures and get a more consistent product. And so it's made that job a heck of a lot easier. Just an example of how we can use IoT. I'm going to pause here, Lizzie. I'm covering a lot of ground. I don't want to go too deep here. Give me some direction. Are we on the right track so far?
Yeah, on the right track. I love to, at the end, when you just kind of pull it back to, this is an example of. And so, yeah, I think these are excellent examples. And you see the advanced manufacturing component. So, when technology meets manufacturing. So yeah, great examples.
Awesome, good. So let's say that you're the CEO at the company and you go, hey, Justin, we've got some really good IoT use cases. The next thing we do is we go in and we deploy some of those sensors. So the infrared wall-mounted temperature sensors, that's one example. There are a ton of things that we can go and put out on the manufacturing floor. It's really interesting to start capturing the data. And then the future case is running analytics on that data. So when you can start correlating multiple variables at the same time, you can pull in relative humidity, temperature, and vibration, then you can end up doing more predictive and preventative analysis using AI, artificial intelligence, to kind of correlate some things that you think may happen in the environment. So that's future stuff, but it's really not that far down the line. It's here now for some companies, and it just depends on the product and the use case of where you're putting this stuff.
Justin, I have one quick question, if you don't mind. And I know OMEP is helping find these solutions for these companies. Do you also, like these sensors, I see OMEP written on it. Are you also developing in-house some of these solutions?
So yeah, the box that's our solution right there. This little guy. And then these sensors over here, these are just off the shelf NCD sensors. There are a couple of other really good manufacturers that have kind of a gateway sensor setup that you plug them in, you format them, and you get the sensor talking to the gateway talking to a Wi-Fi network, and you can put this together pretty quickly. So we've done some development in places where we couldn't buy what we wanted, but by and large, we're buying the rest of the products off the shelf.
Got it.
Yeah.
Great.
Yeah, it's amazing how quickly you can get sensors up and running these days. And yeah, I mean, literally there are hundreds of different sensors you could choose from and thousands of use cases of places you can put them. And it's only with time that we kind of start playing with them, we can start realizing where the use cases are. And so that kind of touches on some of the skills that we find as really valuable when we are working in manufacturers. The people that can tend to gravitate to roles where they are doing this type of work are people that are super curious and they're critical thinkers and they're good at putting together hypotheses. Like, hey, if I put this sensor here, it might track this particular parameter where we've been having problems. Can we try that out? And then they have a lot of curiosity and drive to get through to that stage where they get the sensor installed and start collecting data, and then they can kind of revisit their hypothesis and figure out if it was correct or if they need to adjust it. So that's that. One of the last big things we're doing here is collaborative robots. I know you guys are already kind of scrubbed in on this part of the work. So a collaborative robot is one that you can have working side by side with people. So there are industrial robots that are big, fast, and they may have sharp or pointy things on the end of them. So you don't want them working right next to somebody because we can get hurt, or they could smack somebody or hurt somebody or pin you against a wall. But a collaborative robot is one that is small enough and agile enough that it can, you can put it side by side with a human. It has force torque sensors in each of the joints. And so if it comes up against something that it doesn't expect, once it exceeds a certain force and torque on that joint, basically it'll shut down. It'll kind of go back to its home position so that it doesn't get any worse. But there are a ton of use cases for these small robots that can work right next to humans. Things like packaging and building boxes and moving a predictable widget, from point A to point B, or doing manipulation where they pick up a bottle and they turn it upside down and set it on a fixture. They use them for what's called machine tending. So, and there's Justin is going to talk to you about the CNCs you guys run. If you're running big milling machine centers, it's not uncommon to have a small robot that will pick stock up, put it into the machine center truck, basically get it oriented, and then start the program. And then when it's time to do a changeover, a manipulation, or flip of the stock, you can do that with a small robot. That way, you could have one human person tending a whole bank of machines, a dozen or so machines, instead of having one person per machine doing the work that the robots can do. So it's collaborative robots.
And we did have a cobot at Spark Lab temporarily. So that's, as soon as I saw that, I was like, oh, I know exactly what that is.
Yeah.
That's pretty cool.
And one of the hallmark characteristics of a collaborative robot is it's easy to program. Basically, you do it by guiding and moving and getting the robot to go places where you want, and then you drop these kind of anchor points, and then you run the program where the robot goes, and it'll it'll basically follow the path of the anchor points that you've set, and it'll do whatever end effector manipulations that you've programmed in there. And it's super easy. And I mean, anybody can do it. But it's another example of where moving into a new organization, there are established folks who are not interested maybe in bringing robots in. And so there's a lot of space for young folks who are interested, passionate, and excited about this technology to go and kind of be the technology integrators.
Yeah. Our county is full of robotics clubs at the high school level and even at the middle school level. And so I know that this is going to resonate with a lot of students out there who are already doing some of, maybe not this work, but working with robots, definitely.
That's good.
That's awesome.
Well, Lizzie, that's really kind of what I have here for you guys.
Excellent.
I might just kind of send it back to Justin so that he can talk about his stuff.
Yeah.
Yeah, I'd love to. And I would add just the Cobots Sawyer, I believe his name was.
Yeah.
We had a group of 29 students in here, and by the end of, we had a trainer come in once a week for about hour and a half, maybe 2 hours. And by the end of a couple of weeks, we had some students who were really into it, and they could program pick and place, where that robot could actually locate something, pick it up, place it where you want it to. And they were really fluent at it. They were really into it. And like, can I know more about the back end, how it's programmed and all that? And
wow.
Yeah.
That's super cool. I didn't know we had students actually like manipulating the robot. That's awesome.
Yeah.
Very cool. So folks, we're going to pivot just slightly. So Justin just talked to us about OMEP and the future of manufacturing in Oregon. And Justin is going to kind of bring it back down to like an actionable student level. So our organization, Connected Lane County, opened up a space downtown right next to the Holt Center that's open to students for after school programming and then for a bunch of summer programming. And we have a lot of really cool equipment, and a lot of that is manufacturing equipment. So Justin's going to show us around Connected Lane County's Spark Lab building. He's going to have to move his laptop, so if you get car sick, maybe look away.
Yeah, fair warning. Yeah.
Yeah.
Yeah, and please, if anybody is, just kind of, I guess, turn away. I guess I can't mute my screen, but I'll try to keep the movement to a minimum. But yeah, so right now I'm in Spark Lab. I'm just going to do some tabletop shifting here. So there's the front room out there. Looking at, if you could see out the windows, which you can't because of the sun glare, that would be the Holt Center right across 7th Avenue. There's a screen press for t-shirt printing over there. This is our testing out some green screen equipment. We're hoping to use pretty soon, but that's going well. So if anybody is into videography, we're hoping to provide a little bit of everything. So that giant blue box over there is a laser engraver, not only engraver, but a cutter as well. It's about a 60 watt CO2 laser, so it can cut through about 1/2 inch plywood. Wow. So it's not to be toyed with. But again, those are in some high schools, so it's a very safe machine if you know how to use it properly. And so that's part of what we hope we offer at Spark Lab. You know, giving youth a chance to just learn, you know, put your toe in the water, you know, it can't hurt. You know, come and learn the ins and outs of some of these machines. So over here across this wall, those are a couple of vinyl cutters. And I'm gonna do kind of a spin here, don't get too sick on me, but on that wall is our a word cloud that a group of students made during a 2-week, it was called the STEM Maker Lab Camp. And they did some brainstorming about some words of what Spark Lab means to them and what it means to the community. I'll come a little closer so you can see it because sometimes it has some glare. But yeah, they spent, the first week they made that with some education in 2D design software. Actually, they just use Procreate, which students out there are very fluent in already. I was amazed some of the stuff they were making just right off the bat. Yeah, and then they design it, you know how to use the machines, cut it, and then weeding out the vinyl and getting up on the wall. Over in this corner, we've got a little 3D print farm. The computer on the corner there has a 3D scanner above it, so you can actually put an object under it, scan. Yeah, if you don't want to engineer it and put it in the computer, actually redesign it in the computer, you can give it a scan, put that in your computer, and then tinker with it from there. But between six 3D printers, we can do a lot of prints. Prints take some time, but we had a group of 30 students, and they were each able to have projects printing all the time, and those are pretty safe. They can go overnight without human attention. So they have sensors in them, just like Justin was saying earlier. There's sensors in there with, if temperature reads too high, it shuts off. If the filament coming in runs out, it shuts off. So again, we feel pretty good about that. Heat press, if you're making like a lot of different things, but like vinyl, heat press vinyl. If you want to design something in vinyl, print that out or cut it out, and then put it on t-shirt or pants, or we have some presses for shirts, some presses for hats. So it has like a curvature to it. Cups. You can do all sorts of merchandise. This is our construction zone. It's still in the works, still under construction. In the back, yeah, there's some typical drill press and lathe. But over here is our new. Going to get both of them. This large machine right there, the wide one, is our CNC router. Thanks. And then around here, the smaller is the CNC mill. We have a few more of these coming. We're really excited about these because if we think of Spark Lab offering kind of a pathway, it's a really nice sort of procedure going from kind of 2D vinyl, a little bit low tech, going into like the laser engraver, which is mostly just 2D, but you're going into sort of some depth there, and then you go to the 3D printers, learning how to design 3-dimensional objects and make those happen, and then you can move on to the CNC. So you're the CNC has a bit more danger element to it because if those are drill bits spinning at 12,000, 15,000, 20,000 RPMs, and so if something does go wrong, if it hits a bolt or something, there can be quite an accident. So we do want to make sure everyone's being safe and properly trained. So, but that's part of manufacturing too. Knowing those safety protocols, this would be a wonderful place to learn that and get used to being around those kind of machines. So. Yeah.
Well, and I think key words there: learning and training. So the students from the camps this summer came in with no previous experience. They weren't necessarily enrolled in CTE courses, and they were trained up during their 2 or 3 week camp.
That's correct. Yeah.
Pretty cool. Pretty cool. So they could be trained at Spark Lab, go off to college, and then potentially work at one of the companies that OMEP works with.
Yeah. Wonderful.
It's a big pathway. It's a long one.
Yeah.
Awesome. Very cool.
That's great. We are big fans of kind of makerspaces, Spark Lab type areas. Because, oh my gosh, like what an environment where you can just kind of let your creativity go. The truth is, it doesn't even really matter if you make, at least in my opinion, it doesn't matter if you make anything that's actually useful.
Right.
It's about experimenting and hypothesizing and playing with the tools and toys so you can get a sense of how they work. Because at some point, at least in our environment, oftentimes you will find a good use case where you're like, oh my gosh, now I know how to use that lathe, and I can go turn a shaft that I need to fix this motor. But if you aren't familiar with the tools, then it's likely you're not going to connect the tool with the use case when that opportunity arises.
Yeah, that's the biggest thing. Right? Most students, when they came in, they had one little interest of something. You know, maybe they'd done robotics and Legos or something, or they had done a little bit of coding, like block-based coding or something like that. But by the time they left, they had been exposed to so many other things. They felt just really comfortable here. That's kind of our goal, is being comfortable around these machines, not being afraid to try it, and then maybe they'll sign up for a CTE program or a semester-long course in engineering or drafting or whatever it might be. But it's kind of broadening those horizons of what they've been exposed to and their experiences in using those skills.
That's great.
Yeah.
That's excellent. Well, this worked out really nicely as kind of a compliment. Thank you to both Justins for your time and all the information that you shared. Very grateful for this, and we will be sure that local CTE teachers do have a recording of this video so that they can share it with students.
Fantastic.
Alrighty. Well, happy Thursday, and we will see students in November for our Tour Tuesday and Working Wednesday series. But for now, that's all we have in October. Alrighty. Bye, everybody.
Bye-bye.